So question 2 is looking at prime factor tree and power review. So let's have a look at A. It's asking us to draw a prime factor tree of the number 30. So I start with 30 and I need to break it down. Now 30 can get broken down into 2 times 15, and I know that 2 is a prime number. So remember to keep your prime numbers handy. So I'm going to write them along the top here. I've written them in the box on the other side. The first few prime numbers are 2, 3, 5, 7, 11. Okay, so they're the first 5 prime numbers, so we won't need any more than that. Now 15, it's not a prime number. It can get broken up into 3 times 5. But I know that 3 is a prime number. I'm just going to put in little multiplications here just to keep you thinking about it. Okay, and so 3 is a prime number and 5 is a prime number. So therefore, the prime number tree for 30 is 2, 3 and 5. Okay, so just to finish it off, I would write it as 30 equals 2 times 3 times 5. And always just check that that's right. 2 times 3 is 6 and 6 times 5 is 30. Part B is asking us to draw a prime factor tree of the number 196. Now this is a much bigger one, isn't it? So let's, again, it's an even number at the end, so we can break that into 2, and we know that that's a prime number. You're allowed to use your calculator to help you out. 196 divided by 2 equals, that's going to be 98. So 2 times 98. 98 is an even number, so it's definitely not a prime number. Let's divide it by 2 again. And we get 49. We know that that 2 is a prime number, looking up at our prime numbers. Now what can 49 get broken down to? Well, it can't be divided by 2. And I know from question 1 that it was a square number of 7 times 7. So I can break that down, and 7 is a prime number, so I can't break it anymore. And so therefore 196 equals 2 times 2 times 7 times 7. Okay, excellent. So let's just put that into our calculator to make sure that it's the same number. Yep, brilliant. Alright, now part C. Write the number 144 as a power of its prime factors. Okay, so firstly we need to find its prime factors. So let's do that with a factor tree. And again, it's an even number, so we know we can divide it by 2. I'll just make that, keep it with the red to circle them so you can see. 144 divided by 2 equals 72. That's another even number, so I know that it's going to be another even number there, so I know it's going to have a factor of 2. I get 36 there. Now I remember from question 1 that 36 can be broken up into 6 and 6, but remembering that, so I know that 36 is 6 times 6, but we need to find its prime factors. 6 isn't a prime number, it's an even number, so I can break it up into 2 times 3 and 2 times 3, and all of those are prime numbers. So that's the end of our prime factor tree, but we haven't quite answered the question yet. it is write the number 144 as a power of its prime factors. So now I need to write 144 equals, and power, remember the powers are those little numbers that mean we're multiplying the number by itself multiple times. So let's count how many 2's we've got. I've got 1, 2, 3, 4. So I'm going to do this the long way just to show you. So it's going to be 2 times 2 times 2 times 2. Then I'm going to bring another colour in. And how many 3's have I got? 1, 2 times 3 times 3. I've got 4 2's, so that's 2 to the power 4. Remember, the power tells us how many times we're multiplying the base number by itself, times 3, and that's multiplied by itself twice, 3 to the power 2. So therefore we've taken 144 and we've found its prime factors, and we've represented the answer as the power of its prime. We'll do question D and E in the next video.